Hello everyone. In this session, we are going to discuss about hypothesis testing in research methodology. So basically, hypothesis testing is a statistical method which is used in research to assess the validity of a hypothesis or any kind of claim about population parameter or the relationship between the variables. It involves collecting and analyzing the data that determine whether the observed results provide sufficient evidence to support or reject the null hypothesis in favor of alternative hypothesis. So these are some of the keywords like null hypothesis, alternative hypothesis, which we have discussed in our previous lectures. If you haven't watched them, kindly go through that lectures. The link is mentioned in the description section. And here we are discussing hypothesis testing, where these keywords which we have discussed before are used, right? So basically, there are relationship between the variables. We need to collect the data, we need to analyze the data, and it is a kind of testing in which whatever claim is made by the researcher, which is valid or not based on the sufficient evidences or their support factors, are done tested, right? That is a hypothesis testing. Sum up, we can do like hypothesis testing is an essential tool in scientific research which allows researcher to draw conclusions, to make inferences and contribute to the advancement of knowledge in various fields. It is a basic definition. Now let's move to the characteristics of hypothesis testing one by one. So the first one is, your hypothesis should be clear formulation. That is, hypothesis should be clearly stated and specific, indicating the expected relationship or difference between variables. The null hypothesis, which is represented as H naught, represent the default assumption, while alternative hypothesis H1 expresses the claim or effect the researchers want to support, right? So the formulation of hypothesis should be clear. The second characteristic is statistical significance. Hypothesis testing employs statistical methods to determine whether the observed results are statistically significant or not. It quantifies the likelihood of obtaining the observed data or more extreme data. If the null hypothesis were true, the significant level alpha is predetermined, typically set at 0.05 or 0.01 to determine the threshold for rejecting the null hypothesis. Sample based inference. Hypothesis testing is based on analyzing a sample of data to make inference about the population. The sample is selected in a representative manner, and statistical techniques are applied to estimate population parameters and assess the validity of hypothesis. Test statistics. Test statistics are calculated to quantify the discrepancy between the observed data and null hypothesis. The choice of test statistics depends on the research question and the type of data being analyzed. Commonly used test statistics include t-test, chi-square test, f-test, and z-test, which we are going to discuss in our next lectures. P-value interpretation. The p-value represents the probability of obtaining the observed data or more extreme data. Assuming the null hypothesis is true, it is compared to the significant level alpha to determine statistical significance. If the p-value is smaller than alpha, it means that if the probability of observed data is smaller than the significance level, then the results are considered statistically significant, which provides evidence against null hypothesis. Type 1 and type 2 errors. Hypothesis testing involves the possibility of making errors. Type 1 error occurs when the null hypothesis is incorrectly rejected, right? That is a type 1 error, indicating a significant effect when none exists. A type 2 error occurs when the null hypothesis is incorrectly retained, missing a significant effect. Researchers aim to minimize the likelihood of these errors by selecting appropriate sample sizes and setting significant levels. Generalizability. Hypothesis testing aims to draw conclusion about the population based on sample data The results obtained from the samples are generalized to the larger population, assuming that the sample is representative and statistical assumptions are made. Replicability and transparency, very good characteristics of hypothesis. Your hypothesis should encourage transparency and replicability in research by clearly stating hypothesis, documenting the statistical analysis procedures, and reporting p-values and effect sizes. Other researchers can replicate the study or conduct meta-analysis to access overall evidences. Apart from it, we can say that hypothesis should be clear and precise, which we have discussed. Your hypothesis should be capable of being tested, right? Hypothesis should have relationship between the variables. It should state the relationship between dependent and independent and various variables, and it should limited in scope and must be specific. Your what we say that your hypothesis should be specific and limited in scope, and it should be consistent with most known facts. It should be consistent with most known facts, and hypothesis should be amenable to testing within a reasonable amount of time. So time factor should also be there, right? So these are some of the important characteristics of hypothesis testing. In our next lectures, we are going to discuss more about parametric and non-parametric types of hypothesis, right? So till then, please like, subscribe. If you are having any doubt, please feel free to ask. Have a very nice day. Jai Hind, Jai Bharat.